All right, there's no cosecant button on your calculator, but you know cosecant is the reciprocal of sine, so you're going to type 1 over sine to get a cosecant. But if you need an inverse cosecant, it doesn't make any sense to flip the angle that you would get from an inverse trig function. So what you do instead is you flip the input. So you make it an inverse sine, and you do the reciprocal of the input. Okay, these work the same way. If you want a secant, it's 1 over the cosine. But if you want an inverse secant, it's inverse cosine and flip the input. So 1 over the input. Cotangent, you're going to flip the tangent. When you do an inverse cotangent, you can try it with a tangent, but you have to be careful because inverse cotangent and inverse tangent have different answer ranges. So you would have to take your answer and adjust it if needed. So you just want to be careful of negative inputs on that one. Okay, so in a previous class we did 1, 2, and 3, so we're going to come down here. Tangent. Is there a tangent button on your calculator? Yeah, so that one's fine. Inverse secant, what we're going to do is change it to inverse cosine, and we're going to flip the inside. So let's write out how it's going to look on the calculator. You need the tangent. Instead of secant, you're going to write inverse cosine. And then you need the reciprocal of the input, so 1 over negative 1.287, close. Okay. I believe that this worksheet was done in radian mode. So if you're like checking it against answer key, it would be radian mode. On your review and on your test, it's going to be degree mode for everything. Okay? So today, radian mode, but review and test, degree mode. So press mode. Change to radian for now. And we're going to do tangent, second cosine, 1 over negative 1.287, close. Bless you. Okay, it says to round to the nearest thousands up here, so we're going to round it negative 0.810. All right, next one. Arc cosine is the same as what? What is the same as? I think I heard somebody say it, but it wasn't loud. Inverse, good. Arc cosine is the same as inverse cosine. So there is a button for that, and we said there is a tangent button, so this one you can just type in, okay? So just type that in. All right, so that one said it had an error in the domain. Anybody else get an error? All right, let's see why. Let's just type tangent of 5 pi over 12. Tangent 5 pi over 12. All right, so that number is bigger than 1. And we can't have an inverse cosine with an input that's bigger than 1, 3.73. So that's why that one's undefined.
You don't change tag because like there's no tangent on the calculator.
Say that one more time.
You don't like do the tangent.
Right. And since you already have a tangent button, you just leave it be. Okay? So if you have the button, you don't change it. Right here, I didn't actually change anything when I wrote inverse cosine. I just wanted it to look like the button on the calculator. All right, here though, I think we have to make 2 changes. So this is really a good problem to focus on. This is a regular secant, so you want to go up to your regular secant, and we're going to change it to what? No secant button, so what is it? 1 over cosine.
Inverse sine.
Okay, so then instead of inverse cosecant, we need inverse sine, and then what?
And then it's
1 over the input. Okay, so we did 2 different things. For secant, we changed it to 1 over cosine. And for inverse cosecant, we changed it to inverse sine, and we took the reciprocal of the input. So that's how you want to enter it on your calculator. Okay, did you guys get the same? How would you round that number? Anybody have a guess on how to round that number? You have a guess? No? We have to round to the thousands place, but we have a 9 here, so what does that round up to? Yeah, 1 over here. Okay. Okay. All right, any questions on that section before we go to the next section? In this section, we're solving trig equations. Now, remember your warm-up question was to explain the difference between solving a trig equation and evaluating an inverse trig function? We did both of those things in this unit. When you evaluate an inverse trig function, how many answers do you get? For a function, every input has how many outputs? Just 1, right. So you should get just 1 answer. But now when you solve a trig equation, you can get more than 1 answer. So solving an equation you can have more than 1 answer. What mode should our calculator be in for this section? Degree mode for this section, good. So press mode, and you want to change to degree. Okay, step 1 says apply the inverse. I know some of you have done this problem already, but it's a very basic problem. It's a good one to go over. Do inverse tan. And the reason we do that is because that will get the theta by itself. So I did that on both sides. Theta's by itself. And now type it in. Okay, so we get about 81.9 degrees on that one. So theta could be 81.9 degrees. But over here it's telling you the inverse yields only 1 solution, and we know that there are 2 solutions. So what we're going to do is draw a picture. So here's 81.9 degrees. And it's here because tangent's positive in the first quadrant. But where else is tangent positive? Here? Okay, first and third, because in the third quadrant you have a negative x and a negative y, and they cancel out to make positive. All right, so here's what you're going to do. You want the same reference angle. The reference angle is between the x-axis and the terminal side. You want the reference angle to be 81.9 degrees. But what we need to know is how big is this whole angle here? All right, so who can tell us how big that angle is? Some of you have done this problem, so you should be able to help out. We're doing the tangent theta equals 7, and we're trying to figure out how big this angle is. And we got that by adding what? What did we add?
It was 180.
Yeah. All right, so our first theta was 81.9, and our second theta we got by adding 81.9 plus a half circle, 180. And that was 261.9 degrees. So we have 2 answers. And the reason we have 2 answers is because even though we applied inverse trig, it started as a trig equation. So if it starts as a trig equation, you can have more than 1 answer.
do you know the line goes like that?
So the first one we graphed the answer we got, right?
Yeah.
And then we knew that tangent was positive in the first and third quadrant. So we drew the angle in the third quadrant. For tangent problems, they'll be opposite of each other like that, but for other problems, they won't be. All right, so we're gonna skip ahead. We do have this as a PDF on Blackboard, but we're gonna skip ahead to the last problem in the notes because we haven't done that yet. It has multiple angles, so it's a little bit trickier. All right, so skip to the last one in the notes. Sine 2 theta equals 0.85. So we still start by doing inverse sine on both sides. All right, and I don't believe most of you have done this one yet, so make sure that you are following along here. Inverse sine 0.85. This cancels, and we're going to type in inverse sine of 0.85. So I get 58.2 degrees. Okay. And that's 2 theta, but I'm not ready to divide it yet. I want to find both of my 2 thetas before I divide. So here's 58.2. Bless you. And the sine is positive in the first quadrant, and what other quadrant? The second quadrant, because sine is the y value. So sine is positive in the first and the fourth. So my reference angle is going to be 58.2 degrees, but that's not what I want. I want this. Okay, so how can I find out how big that angle is?
90 minus 58.2. You can do 90 minus 58.2 and then add that to 90.
Okay, so 90 minus 58.2 would give me this piece here, and then you could add that to 90 to get this piece here. That would work.
Or do
180 minus 58.2.
180 minus 58.2, that would do it in one step. Okay, good. So let's do 180 minus 58.2. Okay. All right, so 2 theta could equal 58.2, or 2 theta could equal 121.8. Now, do you guys remember when we did these multiple angle problems before without the calculator, we got twice as many answers? Or if it was a 4 theta, we got 4 times as many answers? So this is going to happen here too. And the way you find those answers is you start with the general solution. So instead of 2 pi k, since I'm dealing in degrees, what should I add? Start with 360, and then we'll divide it. So I have 360k plus 360k. And then I'm going to divide by 2. So I'm going to get theta equals okay. So what that means is I have answers at 29.1 and 60.9 degrees, and then every time I add 180 degrees to those answers, I'm going to get more answers. Now, the directions were way back at the beginning, but the directions said I want the answers between 0 degrees and 360 degrees. So remember, that means the square bracket means including 0, not including 360. All right, so 29 degrees is an answer. And if I add 180 to that, I get another answer. What is that, 209.1? 60.9 degrees is an answer. And if I add 180 to that, I get another answer. Okay? So multiple angle problems are going to get more answers. All right, so I'm going to pause there. And if you're missing any of the others, you can get those from the PDF.